feet. Yep.
Thank you so much. All right. Sorry, my voice is like super projecting. I'm gonna have to like hold my mouth back a little bit. Okay, let me make sure I can do this. Great. So, like I said, my name is Jacqueline McGrane. I'm the Senior Vice President of Business Development for Boulder Creek Technologies. I am also the Chief Science Officer and on the board of Cultiva, a processing and analytical testing facility in the Lao Democratic People's Republic. And we are going to talk today, though, about the future of cannabis extraction and how to scale solventless. And I want to introduce you into what vapor static technology is. It's really exciting. So if I can just press the button to make it go forward, which it's not doing. Dang, I was hoping, I know. I was hoping it would work out. Okay, there we go. Yes, success. So, first of all, why do we want to talk about extracting technology? I know a lot of the speeches today have been about business, about pharmaceutical development, about medicinal aspects. Well, we want to talk about it because all of these products start off as flower and become a final consumer product that people ingest through some level of extraction. And extraction increases the accessibility of cannabinoid products and hemp products to the customer. Just like you mentioned, you know, we don't really like smoking flower. I don't like smoking flower. I like to use concentrated products that are formulated for specific effects. And so finally, extraction is where a company can use creativity and good science to create unique products that increase brand recognition and customer loyalty. So that's why I wanted to talk about extraction technology and why I've dedicated the last 10 years of my life to extraction tech and how to take that flower and turn it into beautiful end products for the customer. So first of all, what kinds of extraction technology are available on the market? You know, I just want to kind of do a basic analysis. I only got 15 minutes, so I'm going to go pretty speedily. So there's two different types. You have solventless and solvent-based. From the solventless perspective, you have heat and pressure, which creates rosin. You have mechanical separation of trichomes, which makes bubble hash. And then finally, what we're going to be focusing on today is this new technology of vaporization, and that is Vapor Static, the company that I represent. Finally, there is solvent-based methodologies. We have, of course, supercritical fluid, CO2. A lot of people like to think that CO2 is not a solvent-based methodology, but it is. And you have solvents, ethanol, and you have non-polar solvents, hydrocarbons. So this is the range of methodologies that you can use to take flower and make it into a concentrated product. And then you can take that concentrated product and formulate it into anything that you want. So we're going to talk about disadvantages first of solvent-based technologies. So the main methodologies that are used today to extract flower material are ethanol, CO2, and hydrocarbons. And you know, we'll talk about why that is in a moment. But what I do want to focus on is the disadvantages of using these solvent-based methodologies, and there are several. The first is safety. You know, as we all know, and we might have experienced ourselves, there has been a lot of issues with both recreational and medicinal production facilities burning down. And so if you look here, this is an interesting study, and I'd be more than happy to send it to anyone who's interested in reading it. This is in the state of Colorado after legalization, after Amendment 64. And they did a study on the first few years of people that presented with burns, actually, from specifically butane hash oil hydrocarbon extractions. And 29 cases of BHO burns were admitted to the local burn center during the study period, and 0 cases presented prior to medical liberalization. So what this means is that with the massive increase in production of cannabinoids, there's also been an increase in safety concerns and safety issues. So this right here, the explosion and fire kills 2 people, that was actually the COO of a major extraction equipment company. So a person who was highly experienced. Yep. And that's how dangerous that is. Now, no one died in this fire, but they did sue the company and run it out of business. So, that's the danger that you face in extracting a cannabinoid material. This specifically was a BHO fire. However, there's been significant amount of fires with ethanol, and there's even been safety concerns with CO2 that is operating at thousands of PSI of pressure. If you get one of those gaskets wrong, if you don't tighten it, it definitely presents an explosion hazard in the form of very high pressures. So, can you just click on it and stop it, please? And then, yep, and then if you could just click to the left, and that should bring me to the next one. Just go a little to the left to the presentation itself. There you go, perfect. So next, we talk about efficiency. Solvent-based methodologies all require many steps to get to the final product, a lot of steps. So I'm just going to give one example, the ethanol processing flow, how to take biomass and get to a ready-to-distill concentrate. So first, you got to cryogenically cool your ethanol solvent. Polar solvents tend to extract significant amounts of wax, fats, and lipids, which destroy your thin film distillation and short path distillation systems. And so you need to ensure that your ethanol is extremely cold so you're not extracting that wax. That costs a lot of power and that costs a lot of money. Next, you have batch-based, generally centrifugal, but there are a few other methodologies, extraction and separation of the hemp cannabis biomass from the cannabinoids. So you see it, you have a person that's filling up a bag and putting it into a centrifuge, extracting it, and then running the centrifuge and recovering the solvent. And that takes a lot of labor, and that takes a lot of infrastructure. You have to house all of this in C1D2 and C1D1 based safety enclosures, and that costs hundreds of thousands of dollars even for the smallest facilities. Next, you have micron level filtration of the extraction slurry. Again, with polar solvents, you're extracting a lot of sugars, chlorophylls, wax, fats, and lipids, even if you're using cryogenic extraction, so you do need to filter at a micron level to achieve anything that's even close to being able to distill. And then you have solvent recovery using either membrane filtration systems or membrane filtration systems followed by falling films or falling films. Again, all of these are enclosed in C1D2 environments, and all of them cost a large amount of money to operate and each require a significant amount of labor. Also, they're all batch-based methodologies. So you're doing one batch, then the next batch, then the next batch. You then have to solvent, you have to polish that solvent in a rotary evaporator or a second FFE to remove it down to levels in which you can then distill it. And finally, you got to decarboxylate and degas it in a vacuum reactor before you can even get to distillation. Finally, you got to remove the residual solvent from the biomass material before you can even dispose of that solvent and get it out of your facility. So all of these steps are just to get to a crude concentrate that then you can distill or then you can turn into and formulate your final products. There's a huge amount of cost involved, there's a huge amount of labor, and there's a huge amount of infrastructure required to house that safely. And even if you house it safely, you can be the safest operator on earth. One mistake, the whole thing burns down. You lose everything. So, now, don't get me wrong. I spent 5 years running solvent-based methodologies. I've designed 10,000 kilogram a day ethanol processing hemp facilities. So I know how to do solvent. I believed in solvent for a long time, and it was only when I met the guys from Boulder Creek Technologies that I found and became excited about solventless technologies. But finally, I'm just going to go into the last major disadvantage, and that's sustainability. Like we mentioned before, power, labor, space, and of course, your solvent recovery is never 100%. A lot of manufacturers like to say 98, 99% solvent recovery. I've never seen really anything close to that. Usually I see somewhere between 90 and 95% recovery. So of course, in the United States, we have federal excise tax on ethanol. So ethanol is extremely expensive, and you're just losing that to the atmosphere. CO2, you're venting a significant amount of CO2 into the atmosphere. Hydrocarbons, you're venting a significant amount of hydrocarbons into the atmosphere. This costs you money, and it also hurts the environment. So we're selling a natural product that many people use as a powerful medicine. Yet the way in which we are processing that product is destroying our environment, exposing workers to safety risks, and costing so much money that many of the products that we produce are so expensive that they are not accessible to customers, right? Even in states that have glutted markets, I'm still paying $60 for a 1 gram vape cart. That's ridiculous. And that basically prices people out of the capability to benefit from the thing that we believe in, which is the flower and plant material and cannabinoids. So why is that? Why do we use solvent-based methodologies if there are so many disadvantages? And previously, it has been because of the fact that solventless methodologies have been so inefficient and they have not been scalable. Now, rosin and bubble hash are awesome products. I personally prefer to use vaporize live rosin at home. That's the product that I use a lot of. But it is so inefficient to produce, and you just can't scale it. You can only make very small amounts of it. And so consequently, when we're talking about production facilities that might have tens of thousands of square feet of grow, might have hundreds of thousands of pounds of biomass, you just are never going to be able to run a solventless methodology to extract those cannabinoids effectively and efficiently. So, talked about that. So solventless couldn't compete. And because it couldn't compete, we went with solvent-based methodologies. So, but not anymore. So, I'm going to introduce to you vapor static technology and what it is. This is a picture of our Tsunami 5000. It is a 5,000 pound a day solventless extraction system. So how it operates is by using hot air to vaporize cannabinoids and terpenes. Now, this has been done for 20 years, right? The volcano vaporized cannabinoids and terps. What's so special about that? Well, what's special about it is that we can then condense that back into a liquid highly effectively. You could not do that before. Many companies attempted to do this, and they failed because they could not condense it back into a liquid. GW Pharma, one of their very first patents was attempting to do a vaporization tech that condensed back into a liquid, and it just could not do that effectively. So what we have done is we have actually introduced a technology derived from the pollution control industry. We're using what's called an electrostatic precipitator to take that vapor, it's called a non-coalescing vapor, and bring it back into liquid form. And we are doing that with a scalable function. So electrostatic precipitators, like I said, came from the pollution control industry. They put these things in the size of a building on top of power plants to remove carbon and soot to increase the environmental sustainability of things like coal and power plants. And so, actually the biggest issue for us in terms of scalability was actually scaling it down. But I'm going to go into basically at its core, like I said, VS technology uses heated air to vaporize cannabinoids from biomass material. It then condenses that vapor back into a liquid using a high voltage but low amperage electromagnetic field. It does this automatically, continuously, and efficiently. So this is the symbols of our company. We have biomass, we have heat, we have electricity, and we have oil. That's it. It's a very simple concept, but it's revolutionary. So, the process flow synopsis. First of all, continuous extraction. So air is going to be pulled through the extractor by a fan and heated before entering a flash tube dryer system. That's in this box right here. And inside of that, there's a series of tubes. Now, this is actually derived from the timber industry. One of our big goals with bringing a new technology to the market was to substantially de-risk it. And the way we did that is by taking technologies from other industries and optimizing them for cannabinoids and hemp material. So the biomass is pulled through this series of tubes at 5,000 feet a minute, and the cannabinoids are vaporized as well as a significant fraction of the terpenes. Finally, the post-extracted biomass is removed through a cyclone and then pumped out via a rotary airlock. So the biomass is now continuously entering the extractor and continuously being removed from the extractor. So that means you're not having all this labor filling up bags, running small amounts over and over and over again. You're doing it all continuously and in an automated fashion. The next step is actually custom to us. This is something we had to develop completely from scratch. It's a scrubbing and cooling system. So you're going to get some wax, fats, and lipids that are going to vaporize, and we have to remove them. And we actually use a recirculating water system to both scrub wax, fats, and lipids and other unwanted compounds from the vapor stream, as well as cool that vapor stream and turn it into the non-coalescing vapor that we then are going to be condensing. And so that system actually recirculates water through it. It is not in and out, and it has a continuous and automated burley tank that removes and skims wax, fats, and lipids and pumps it out of the system. You don't have to have anybody there doing anything. You just put a bucket under it or run a pump to your waste, and it will automatically run everything for you. Our recovery of cannabinoids, this is the secret sauce. This is what all of our patents are derived from, and our patents have been given to us by the USPTO. The cannabinoid-containing fog enters the electrostatic precipitator. That's the electrostatic precipitator there. And that uses an electromagnetic field to condense the cannabinoids back into a liquid. So you can kind of see here, the gas containing your particles are going to hit this electromagnetic field. Any sort of particle that has a minuscule amount of charge, when you apply an electromagnetic field, it's going to create a force, right? So basic physics 101. So that particle is then going to flow. Instead of going straight through the tube, it's going to actually curve and hit the sidewall, where it's going to lose its kinetic energy. So if you could play the video, please. So this is the electrostatic precipitator on. There's nothing coming out of that exhaust fan there, just water vapor. So we're going to turn the electrostatic precipitator off, and we're going to show you what that fog looks like. So that's cannabinoids and terpenes right there coming out of the exhaust. That just shows how efficient the electrostatic precipitator is at recovering cannabinoids that are vaporized using the flash tube dryer and ran through the scrubbing system. Pretty neat. So if you could just pause that, and we'll go into the next one since I'm running low on time. I want to kind of explain some more of the benefits. You just got to click it a couple times. Should, like, on the outside of it. There you go. Okay. So the entire system is controlled by a single touchscreen interface. You've just replaced 10, 12 workers with one individual pressing one screen. So the concentrate, it's high potency. Its average potency is between 70 and 80% coming straight out of the machine, which is 10 to 15% higher than most ethanol and CO2-based oils. It will never have heavy metals, microbials, fungals, or mycotoxins. You know, unlike solvent-based methodologies, which do extract those and do end up contaminating end products that have flour that is contaminated, this will not. This will never extract heavy metals. There are no sugars in chlorophyll, which allows immediate distillation of the output concentrate with no further processing required, and it has a low fat and lipid content. This is a picture of the concentrate coming straight out of the system. So that is ready for distillation. That is ready for final products. And finally, we'll just kind of go through because I am out. But you can always go and check out this presentation online. But it's efficient, it's safe, it has easy compliance. We have an 80% reduction in OPEX, as well as a 60% reduction in CAPEX for infrastructure costs, and it's scalable. So low maintenance, continuous processing, and finally, sustainable. You know, we're all trying to create a natural product. We're all trying to create medicine that helps people. We should be doing that in a sustainable methodology. And we should be trying to be having the lowest carbon footprint that we possibly can. But this allows you to do that while also having the lowest possible price, which increases accessibility of your end products to consumers. If you want to learn more, feel free to go to bouldercreektechnologies.com. You can email me at Jacqueline at Boulder Creek Tech, Matt B, our sales director. And you can check out our Instagram, Boulder Creek Technologies. Oh, shouldn't have the .com, but... And finally, you can find me on Chattergirl Jacqueline. Be more than happy to have any conversations, answer any questions that you guys like later on. And it was a pleasure to give this discussion and presentation to you. Thank you for your time.